All right, everybody. So we're going to continue our discussion about linked lists here, and now we're going to start talking a little bit about some of the terminology associated with them, as well as some of the most basic functions associated with lists. Before we kind of go into that too much, I thought we should kind of lay a little bit of a more concrete definition on what a data structure is and talk a little bit about that, since that is, the name of the course. So, a data structure at its most simplest form is really nothing more than a way of organizing data, right? Oftentimes, you're going to encounter, much more complex data than, say, I just have a bunch of numbers I'm trying to store or a bunch of characters I'm trying to store. You're going to end up getting things more like I have this employee record with all of these different fields and all of these different operations I need to perform on it. So, what is the best way to store that data and organize that data? And that is really where data structures come into play. And what we're going to see is that by building different data structures, this is how we are actually going to implement abstract data types, right? In order to implement those interfaces that are exposed by the abstract data types, we will need to build specific data structures and implement them in such a way to get that expected behavior out of them. All right, so that's really all there is to data structures. It's just a way of organizing and applying meaning to data, which hopefully you'll be able to see that quite obviously as we move through the class. All right, so if we continue talking about linked lists now, or just lists in general, these are going to be a data structure that have a specific way of organizing data, right, which we kind of mentioned before. If we kind of look at our little picture of a list down here, what we're going to see is a bunch of these boxes, and these boxes represent individual data structures as well. So what we're going to find is that a list is actually going to be made up of multiple smaller, simpler data structures, and we tie them together with functions in such a way to get our behavior. Right? We mentioned that each list is going to be made up of nodes, of individual nodes, right? And a node is basically, in the most basic sense or most simplest sense, what we'll see when we start writing code is basically nothing more than a structure containing the various fields of data that we want, along with a pointer that allows it to point at the next node in the list. And then to kind of organize all of those nodes in a way that we can kind of keep track of, we may also have this overall just num list or list structure. And that structure is basically going to contain two, maybe three fields overall, depending on how complex you're trying to make your list. And one of those fields is basically going to be the head field, right? And the head is basically just a pointer to the very first element in our list, right? In order to start traversing our list, we need to know where the list starts. And the list, we can use the head in order to find that node or that very first node in the list, right? That's all head is going to be. It's just a pointer to the first node in the list. We can also have the tail, right? And the tail just simply points at the very last node in the list. All right, so by using these two pointers in our just overall list structure, we can more easily gain access to and control how we kind of iterate over our lists, right? We'll see that if we want to print our list backwards, using the tail pointer makes things very easy, or if we want to add things to the end of our list, using the tail pointer makes things easy. Similar to if we want to print our list forward to backwards or add something to the front of the list, the head pointer becomes very, very important. Right? So that's the head and tail of the list, along with the most basic structures we kind of look at. Right? And after we get done talking about this, we'll look at the code that directly kind of represents this picture down here. Right? There's also multiple types of lists. We have our singly linked lists, which is what's depicted down here and what we'll kind of go over in the code. And in a singly linked list, basically each node of our list has the data that we're trying to store as well as a pointer to the node that follows it. Right? So this means that each node only has information about the node that's coming up directly after it. It has no idea what nodes come before it or if any nodes come before it. It only has a link to the following one, right? So it's kind of this chain that we need to keep intact in order to get from the start to the end. However, because these pointers are only going one way and each node only knows about the following node, right, there's no way to go from or print anything from back to front, right? We can only go from front to back because that is the direction that our pointers are pointing at, right? But there are, of course, always ways around that. You can get creative with recursion, you can get creative with stacks, or you could develop a doubly linked list, which we'll talk about as well, where each node has a pointer to the front and it has a pointer to the back, right? As I had mentioned before, we also have our set interface about the various types of functions that we'll use or should be exposed by your list class or your list data type, right? And the two most important ones that we'll talk about are the append and the prepend functions, or these are our most primitive ones so that we can actually start building up our lists. Right, so if we want to just kind of look at our simple little diagrams here, you can see we'll end up creating a list, and that list will have pointers to the head and the tail, and then we'll go ahead and we can start appending things or inserting things into the list. Right, so for instance here, we appended the number 99 into our list. So that means we created one of the structure node structures which holds the data and has a pointer to the following node, which of course there is no following node, so we just set that to 0, or in most cases we'll call it null when we start coding it, and we set our head and tail pointers to point at that singular node. And that's because it is both the head and the tail of the list. It is the first and last element. Right? If we go ahead and we insert another new node into our list, we go ahead and now we set the pointer of our head to point at the new node, because that's the next step in the chain, and then we move our tail pointer to point there because that is the next node that's going to be coming up, or it is the last node in the list. And then finally, of course, if we would call prepend and add a new node to the front, then we would have to adjust our head pointer because we would have a new head that we need to take care of, or a new head of the list that we need to know about. And then that head will point at the old head, etc., etc. And it just continues going on. If we want to look a little bit more in depth at these functions, we can kind of have some pseudocode we can go off of that tells us how the functions should behave, as well as these animations kind of draw it out for us. One big thing I'll say is that if you're having problems understanding why your code might be breaking or understanding how linked lists are working in general, write out your code and then kind of, look at your code as you have it typed out and go ahead and then also draw it out in a way that's kind of similar to this. What you'll find out is that you'll end up finding all sorts of bugs that you didn't know about before because of how you were modifying pointers. If you draw everything out, you're going to see those mistakes that you wouldn't have seen before. All right, so if we look at our pseudocode for our append operation, basically what we're looking to do is the first thing we need to check is if the list is empty. And that's really what this first part of this if statement is saying. It's saying if list head is equal to 0, right? If it's 0, that means we have no nodes in the list and our list is empty. So that means when we create our new node, what we're going to need to do is add our node and then set the head pointer equal to that node and set the tail pointer equal to that node, which gives us kind of this little diagram, right? That this is the visual representation of what this piece of code just did. Right, we inserted our node, we created our node, and we set our head and tail pointers to point at that node because it is both the head and the tail. If we wanted to go ahead and insert another new node into the list, what we're going to find this time is that we check to see if the list is empty, which it's not, right? We can tell that now, and we fall down into our else statement. And this basically says go to our tail pointer and then go to the next field of the node pointed at by tail and set that equal to the new node we just tried to insert. After we create that little connection between those two nodes, we can go ahead and set tail equal to our new node, right? Because that is the new node in the list. and it is also at the back of the list. So we need to move tail to that back spot, right? And that is our append functionality. Pretty simple, just these, kind of 6 lines of pseudocode here. Again, if you have problems with it, make sure you replay this animation, draw it out, and things will start clicking for you. Besides the append operation, we also have the prepend operation, right? And the prepend is where we are inserting nodes at the front of the list, right? So again, we have some similar pseudocode that's very much in the same structure, but prepending is actually a little bit simpler than appending to the list, right? So again, the first thing we'll do when we start looking at our code is we check to see if the list is empty, which if it's not, we go ahead which if it is actually empty, we create our new node. We'll set our head and tail pointers equal to that new node because it's the only node in the list, right? So these two, the if statements, the first part between the append and prepend are exactly the same. Where it changes now is if the list isn't empty, right? So in append, when the list was not empty, we ended up messing with the tail pointer and kind of adjusting things to put the new node into the list. Now, if we are prepending, this time we're going to end up messing with the head pointer, right? So the first thing we'll do there is we'll set the next field of our new node equal to the current head of the list, and then we'll go ahead and set the head of the list equal to our new node, right? So if we animate that, what we'll see here is we're prepending 23 onto our list, but our list is currently empty. So that means when we insert this new node, our head and tail pointers are just going to point at the new node we put into the list, right? Because there was nothing else there before. So they both are just going to head right over there. But now following this, we're going to call prepend again, and this time we're going to try to insert the node 17 into this list. And what we'll see this time is that when we insert 17, our list is not empty. So we create our new node, we fall down to our else statement down here, and now this time we get the next field of our new node pointed at the current head of the list, which is the node 23. Right, so we kind of draw this arrow up to here. And now what we're going to do is we're going to adjust the head pointer to point up to our new node, right? And by doing that, we now correctly fix up all of the pointers so that the list is in the correct order and starts at our new first element in the list. What we're going to see as we go through all of this stuff is that all of our list operations pretty much just end up being lots of pointer swapping and modifying pointers, right? There's going to be nothing too crazy about it. It's just kind of getting the pointer operations correct to make this all fit together. So with that, I'm going to stop this video, and in the next video, we'll look at some actual code for all of this stuff.